today we will discuss with this introduction to trigonometry and in continuation to our part 1 video. Now it is our part 2. It is our part 2 video. Part 2. It is our part 2. Part 2 video. Okay. Part 2 video. So here question number 4. Question number 4. Given cot 15 cot A is equal to 8. So we can write it because here multiply sign is hidden. So it will go to other side and it will go to the below side. Okay. So cot A we can write it 15 will go down. So 8 upon 15 we can write. Okay. And cot is find. You have to find sin A. Sin A you have to find and sec A. Sec A. Okay. This you have to find. So better first we will make a triangle. This is your angle A. Angle A, take it as a B, take it as a C. So cot A, cot A. So you remember our relationship number 6. So this is your base, because A is here, base will be here, perpendicular will be here and hypotenuse will be here. So cot, it is opposite to tangent, means 6th relationship. Our 6th relationship, you remember, 6th relationship was base upon height. So it is equal to base upon height. Okay. So it will be your 8 and hypotenuse, base upon hypotenuse, hypotenuse. So it will be 8 and it will be 15. Okay. So cot A, 8 upon 15. So cot A formula is your P upon B. So base will be 8 and P will be 8. So AC means hypotenuse square is equal to base square plus perpendicular square. Okay. So this is 8 square plus 15 square. So equal to 64 plus 225. So equal to 5 9 6 2 8 289 is equal to H. So H is equal to. So H barabar, it is coming as a 17. Okay. 289. Here we will make it like this. So 1 is equal to 1. It becomes 2. And here 189. Here we will make 7 7 ja 49. So 49 7 14 4 18. So it becomes 7. H is equal to, like this you can find any under root. Okay, first pair this one and remaining like this. So 17. So it is coming 17. Now sin A. Sin A means this to this. Sin A, from here to here we are going to discuss. So sin A is equal to sin A, your P upon H is equal to 15 upon 17. Sec, sin, then other. Now sec, if they want to know sec. So sec is this relationship. Sec is H upon B is equal to 17 upon 8. So this is your answers. Question 5. Given sec theta is equal to 13 upon 12. And calculate all the ratios. Means you have to find sine, then cos, then tan, and then sine's opposite is cosec. Sec, of course, they have given, its opposite they have given, and tan ka opposite cot. So this they have given 13 by 12. So it will be 12 upon 13. Okay, its opposite. So other ratios we will calculate. So we will take a triangle. Okay. And theta is here. Okay, and they are telling it 13 by 12. So the relationship they are discussed, this is your perpendicular, this is base, and this is your hypotenuse, and this is your theta. As theta is used, we are not using ABC. From here they want to find the sec. Sec means h upon b. Okay, so h is your 13 and b is your 12. So perpendicular we will find out. Perpendicular equal to hypotenuse square minus base square using the Pythagoras theorem. Pythagoras theorem we are using here. Okay, Pythagoras theorem. So h is 13 square minus 12 square is equal to 169 minus 144 is equal to 25. Under root is equal to 5. So perpendicular is coming as a 5. Okay. Now all the sine 5 p upon b, sine is p upon b, so it will be p upon b means 5 upon 13. Tan is p upon b, p upon h, and cos is base upon hypotenuse, and tan is p upon b, so 5 upon 12, it will be 5 upon 12. Now cosec means h upon p, so 13 by 5 it will be, and cot will be b upon p, so it will be 12 upon 5. Okay, so these are all the ratios are here. Okay, this 5 is over. Now we will go to question number 6 and do that. Okay. Angle A and B are acute angle. A and B are acute angle. So it is 90 degree, means it will be angle C, it will be angle A, and it will be angle A. One line is here A and B, and it is also an acute angle, and it is also an acute angle. Here they are giving two acute angles, and they are saying cos A and cos B are equal. What they are saying? Cos A equal to cos B. So for how we will know cos? So we have to make some line perpendicular here and make a 90 degree triangle, so that it becomes a right angle triangle, and our cos we can find out. Cos A also we can find out, and cos B also we can find out. So we have made a perpendicular CD. This we have drawn to find out cos A and cos B. Okay, and you have to prove. What you have to prove? You have to prove angle A is equal to angle B. You have to prove this. Prove angle A is equal to angle B. This you have to prove. So for cos A and cos B, we have drawn a 90 degree angle. Suppose this is triangle 1 and this is triangle number 2. Two triangles are there. Okay. So cos A means then this becomes your hypotenuse, this becomes your base, and this becomes your perpendicular. And for this, it is hypotenuse, it is base. Okay. So it is a baseline. It is a baseline. It is hypotenuse, and it is hypotenuse, and this is your perpendicular. Okay. These are the perpendicular. So cos A means perpendicular upon H. P upon H of A is that. Cos A is equal to B upon H of triangle 1 of first triangle is equal to B upon H of second triangle. This they have given. It is given. This is given. Okay. So now we will start B. B means AD. So AD upon AC. AD upon AC. It is equal to what? It is equal to dB upon BC. Okay. So by transposing we can write it dB, we can write here. AD upon dB we can write here, and this we can take to CC one side and DD one side. So AC and BC we will write by transposing. By transposing we can do it. Okay. So this is what we have done, all CC one side and DD one side. Now if we take these are the ratios, so we can take a integer, like say we can say AD upon BD is equal to AC upon BC equal to K. Suppose we have taken a number K and we will multiply this. K a number, a positive number, any positive number, because ratio is there, we can multiply ratio with any positive number. So here, so what will happen? AD upon BD will become to K, and AC upon BC will also be equal to K, or AD equal to this we will taking as a in transpose K into BD. And here what will happen? AC will be equal to K and BC. So this we have done. Now we are using our Pythagoras theorem onwards. So as per Pythagoras theorem, this suppose this CD will be equal to using Pythagoras theorem. What will happen? This CD is equal to CD square. Your CD is equal to hypotenuse square means AC square minus AD square. Okay. In triangle CD, in first triangle, and CD in second triangle, what will happen? Here it will happen BC square minus BD square. It will become like this. So here it means CD and CD is common, and CD. So or we can write CD is equal to this, CD equal to this. So we can write so under root AC square minus AD square is equal to under root BC square minus B or D square. Okay, this way. And now we have find out AD and AC we have find out. So we will replace this with this KBD and here. So AC we can write it AC we can write it K square BC AC square minus AD square how we can write K square or BD square. Okay, is equal to this one BC square minus B and D square. Now I will rub this side and we will then further from here onwards I will discuss. Okay. So now here this we can write K we can put out, and K square minus K square is there. So if you take out K as a whole number, K square K and BC square minus BD square. So if we take K out, what will happen? So K will remain K, and under root what will remain? BC square minus BD square, and BC square equal to BC square minus B and D square. So here this is your common. From this K and K common we have taken out. Common taken out. Taken out. So common we have taken out, so it will K square will come out. So it will become K square will become K. Because square is there, so this under root sign is there. Under root sign is there. So common K2 will come out and it will become K. Okay. So here BC is equal to BD. So what happened? If we have proved, it means BC minus BD are equal. BC minus BD both are equal. BC minus BD in both angle, in both triangle, in triangle 1 and triangle 2, same, similar it is. It is same. So if this is same, means BC and BD in both it is same. So it means DB and AD will be same. So if it is BC minus BD, here also in triangle 1 also it is same, and triangle B also it is the same thing. So it means AD will be equal to DB and AC will be equal to CB. So these are triangle 1 is similar, not similar to triangle B. Now what happens? One theorem is there, 6.2 of Thale. Thale, he has given a theorem that if corresponding lines of two triangles are same, corresponding sides are equal, sides ratio, corresponding side ratio is same, so they are similar, and angle will be equal. This angle will be equal to this. So angle A will be equal to angle B, and it is proved. In question number 6, there is one correction is here. We told theorem 6.2, but read it as theorem 6.4. What theorem 6.4 is saying? In two triangles, sides of one triangle are proportional to the side of other triangle. It means if this line is proportional to this line and this line is proportional to this line, then their corresponding angles, means this angle and this angle, corresponding angles are equal. It will be equal, and the two triangles are similar. So this equal, that is we have to prove. So we already proved AC is equal to BC, AC is equal to BC, and AD is equal to DB. We have proved. So automatically their corresponding angles are equal. So angle A and angle B will be equal. Similar triangles are like this. Suppose one triangle is this and one triangle is this. If their ratio of this line and this line is same, this line same, this line same, then their angles will also be same, and it will be known as a similar triangle. Here proportional means in equal ratio. Okay, so please read that theorem 6.4 in place of 6.2. Thank you. Now question number 7. Question number 7. What is given? We will draw a line. A, B, we wanted to be and C. And suppose theta is here. This is 7 and this is 8. Here in this triangle, they have given cot theta. Cot theta is equal to 7 by 8. Okay, so any angle we can take it. So instead of this, we are taking this as a theta. We are taking this as a theta. So if this is theta, so cot will be will be base. This is base and this is hypotenuse. This is perpendicular and this is your base. So cot will be equal to P upon B. So cot will be, this is your sine. This is your sine. Sine, you term it as a sine. Okay, you remember. From here to here, you term it as a cos. From here to here, you term it as a tan. So cot will be from here to it. So it will be base upon P. So this is given. And what you have to prove? You have to calculate cot square theta. So cot square theta will be 7 upon 8 and square. So it will be 49 upon 64 cot square theta. This is your second answer. First we are doing here. Okay. Now if these are it, we have to find first AC. Okay. So AC will be A and C. AC will be under root AB perpendicular square, AB square plus base square plus BC square is equal to AB is 8 square plus 7 square means 64 plus 49. Under root, it is not dividing. So AC will be under root 113. Don't be afraid, whatever is coming you just write. It is a ratio only. Yeah? So in the ratio, it is not actual line or something. It is a ratio. 113 is here. Now you have to find. You have to calculate. First you have to calculate sine. Sine, because question is depending on sine. So sine will be P upon H is equal to 8 upon under root 113 sine, and then cos. Cos you have to find. Cos is equal to base upon B. So is equal to 7 upon 8. Okay, the sine or cos you have to find out. Now evaluate. Question. Now this is your workings. Now evaluate. You have to evaluate. EVALU. What you have to evaluate? 1 plus sine theta multiplied by 1 minus sine theta. And so here cos sine is this one and cos is from here to here. It is cos. So 7 upon 113. Okay. So this is given and you have to find sine theta upon 1 plus cos theta multiplied by 1 minus cos theta. Okay. So we know the formula A square using A square minus B square. A square minus B square is equal to A plus B and A minus B. This is the algebra identity. So this identity, using identity this, what we will get? We will get 1 square plus sine square theta. No, sorry, this sign will come in minus. Upon this we will get A minus B. And here what we will get? A minus B. So 1 square minus cos square theta. Okay, we will get. So it is 1 is 1. And now sine you have find out 8 upon 113. 8 upon under root 113. And here it will become 1 minus cos you have find out. Cos you have find out 7 upon under root 113. So what will happen? 1 and it's square. and its square. Okay, so minus, it will become minus 64 upon, now this will go out. So, this your root will go out and it will become 113 because we are making square of 113 upon 1 minus 49. Here also due to root will go out and it will become 113. So what will happen? Suppose we will minus it. So here 1 upon 1 is here and we take as a LCM 113. So it becomes 113 and 64. This is your LCM. So what will happen? This 113 makes it 113. So 113 minus 64 it will come. So we will minus it directly. Instead of doing all this, we will minus this from it. So it will come 49. And here what will happen? Again we will do the same thing. Okay, this will become this. Okay, so this will be your second answer. It is your second answer. This answer is this. Okay, and it is your question number 1. It is answer 1. It is answer 2. Answer 2 of question number 7. Now we will go to question number 8. 1 minute. Now we will cover the next question, question number 8, in our next video. Video number part 3 we will be speaking, and in that we will cover onward. Thanks for watching my video. Please share with your friends so that they can also subscribe and watch our further this free online tuition. They can also get the benefits. Thank you.